Okay, Drew, here we go. So I am going to, so I have Unreal open here. I'm just going to start a new, let's do a third person project. And we going here should take a second. I'm using Unreal 5, but it'll work the same in 4 because we aren't doing anything crazy that's specific to any sort of changes in 5. So the way I would handle it, since you've got a couple of different cubes, and eventually you may want to change up a little bit about how you handle them, or add some additional functionality, or different types of cubes. You know, maybe for example, you could add an explosive cube or something like that, where if you connect that one to electricity, it blows up and ends the level, or however you want to do it. So what I would do is create a new blueprint class, create an actor. Actor is just a generic anything that can be spawned and used in the level. So I use BP to preface my, or to prefix, I should say, my blueprints as blueprint. My cube. So we're going to create a parent cube, and then that'll make it a lot easier to manage all the child cubes that we decide to create, all the different types. So this will contain the logic for it, so we don't have to recreate the wheel a bunch of times over. So let's add a cube, our basic shapes, and then I'm going to move this up so it doesn't go through the floor with any adjustments. Alright, and then we also need a box collision. So this collision box, is going to be what determines when you collide with another actor, which is going to be another one of these cubes, or it could be the player or whatever you want. So it depends on, as you can see, we've got a little bit of a gap here. So we need the collision box to extend past the box slightly so that we can tell when something butts up next to it. You can of course make this bigger if you want it to be less particular on how close you get it, which you may want to do since you're moving these boxes around with physics. It might be hard sometimes to get them butted up perfectly, and to make it a little bit less finicky and easier on the players, you may want to extend this box size. I don't know, but we'll try it for here, right here for now. And then, so typically, sorry, you can probably hear my daughter in the background, she just woke up, but typically in game logic you don't want to put much, if anything, on tick, because it runs every single frame. So if you're getting 60 frames a second, it's running 60 times a second. However, the logic that we're running is incredibly simple, so I don't think we really need to worry so much about that. So I'm just going to put it on tick. So let's actually create a function first. This function will be energize me. So this function will get called whenever we are next to an energized source. Here first, you know what, let's actually create some variables. Whoops, I didn't mean to do an event dispatcher. Let me delete that, I meant to do a variable. So we'll do energized. This is if it has power. And then we're going to create another variable called conductive. This is if it conducts electricity. And then so that we can determine when we've got to shut it off, we're going to be checking to see if we still have power every tick. So we'll create another variable called like found energizer to see if we still have a new energizing source near us. Alright, so back to our function, energize me. So when we get power, when we're next to something that has power, and don't worry yet about how we find that, I'll show you in just a second. When we get power, we're going to want to set energized to true, so that other objects near us can tell that we are energized, and they can use our energy to energize themselves also. And then, because I don't have any effects created yet, I would just create something simple in Niagara if I were you, to show when you are energized. But since I don't have anything like that, I'm just going to change the material on the cube. Set material. So we'll just set it to something different. It's going to be that copper, I think by default that's what you had, so let's change it to if it's energized, we'll change it to, let's say, I don't know, Chrome, I guess. Then we also need a function for when we lose energy. So de-energize me. So then when we lose energy, we're going to want to set our energized to off. So we no longer have energy, which should flow down the line to everyone that we were energizing. And then we will also go ahead and set the material. You know what? We need to create a new variable here. Material. Let's call it default material. And then whatever the default material is for this material. So then we're going to reset the material back to the default. So that when it's not energized, it'll go back to whatever you originally set it as. That way we won't hard code what it goes. And I would set the energize me. I would create a variable somewhere that is, you know, for your energize thing, or create, like I said, I would probably prefer to create an effect in Niagara or something. You can create sparks or whatever you want to do. All right, so that should, we de-energize, we set the material back. I think that should be good. So now let's go ahead and make these visible, more so for debugging than anything. And then, let's see. Okay, so on tick, we are going to check and see if we have any overlapping actors with us. So again, this is our collision. So this box right here, we need to see if it's going to overlap with anyone else, and then we check to see if they are energized. If they're energized and we are conductive, oh, you know what, speaking of which, I forgot to add the conductive check. So before we set energized, we need to see if we are a conductive material. Get, so then we'll put a branch in here and say if we are conductive, set us to energized and change our material. If we're not, we don't do anything. Okay, so we will go off of this collision here, this collision box, and get overlapping actors. Overlapping actors. We're actually not going to use that tag thing that I was talking about previously. I kind of misunderstood how you were handling this. So we want to get any overlapping actors. We don't care about overlapping with, say, the ground or other objects in the game. I don't think. If you do, you may need to reduce this class filter and figure that out. You don't have to use a class filter, but it just means you'll have fewer actors to iterate through, so I would think that might be better. So then we've got the overlapping actors. So here are all the actors that we're overlapping with, so other cubes. So then we're going to do a for each loop. And if you don't know about loops, that will help you. So basically this loop is going to go through every actor in this array and do the loop body on each one, and then it'll execute the completed when it's finished. So before I forget, let's make sure that this collision box is set to generate overlapping events. Yes, it is, and we'll just set it to overlap all. And then that's fine. Okay. And then the cube should simulate. We don't care about the overlapping parts with this cube. Simulate physics. Yeah, and so there we go. All right. I just wanted to make sure that was set to just simulate physics and get our overlapping events. All right, so if we overlap something, so then this is going to give us an actor. Let's cast it to my cube. That way we can treat it as a cube. So if it turns out it's something else, we have this filtered, but we could just turn this filter off, right? And then if we get my cubes, we want to handle something specific to those, and if not, we don't worry about it. So you can leave this filter on or off. Doesn't really make a whole lot of difference. I'm going to go ahead and put it back on just because I think it'll run a little smoother if it is, since we're running this on tick. Okay, so as a cube, we then check to see if the item we're overlapping with is energized. Get energized from this cube. So this is the cube we're overlapping with. We see if it's energized. If it is energized, and we're not going to do anything with the cast field, because if it's not one of our cubes, then we just don't worry about doing anything. You could, if you wanted to add something to that, you know, go for it. So if it is energized, then we are going to run energize me, which will energize ourselves, and that'll create the chain. So then, actually, you know what, I forgot to put a little part of our check here, because we need to find out. So I'm going to move these back over here, because we need to check if we found a current energizer, because right now it'll set it to energize, but we're not setting it to de-energize. So let's go to found an energizer, set. Let's set this to false before we check. So before we check to see if we have anything energizing us, we're going to set the energizer found to false. That way we can verify if after this check we actually found something. So let's go ahead and just add it to our function. We set the material, and then we're going to set the found energizer to true. So then when we go through this loop, if we don't find any energized boxes, let's say they're all rubber. If they're all rubber, none of them are energized, which means these aren't going to execute. So then we'll go down here, and we're going to put, actually, we're going to create a branch. And if our found energizer is still false, then we are going to execute de-energize me. Whoops, de-energize me. So we de-energize ourselves if we never found an overlapping energizer to us. Alright, I think that should handle the functionality here for whether or not cubes are energized. So let me dock this over here to the main setting. We don't need project settings. Alright, so now we're going to create some children. Alright, so this is our base cube. The nice thing about using a parent and child setup here is that if we need to make some change to our logic, let's say we change what happens when you get energized, or add a bunch of different types of cubes, we don't have to keep recreating the wheel. So we create a child blueprint class right up here. So let's call this a metal cube. We also need to create another child for our starter cube, because that one's going to be different. And then our rubber cube, or whatever you have. Okay, so let's go into our starter cube and do what we need to do on this. So this, you can see right here, we've got the begin play, and it calls the parent begin play. So this is the child starter cube. So it's going to basically go up the chain to the parent, which is the my cube right here, which would call this begin play on the parent. We don't have anything here, but if we add something later, we want to make sure that gets called. And then since this is the starter cube, I'm really not worried about executing any of this logic on the parent, because this tells you whether or not you are energized. So we're actually going to break this, because I don't want to call any of that, because the starter cube is going to be energized all the time. So what we're going to do is actually just set, whenever this starts, we're going to set energized to true. And since we never call any of this logic that de-energizes us, this starter cube should stay energized all the time. So we can just save that. And let's go ahead and change the look of our starter cube too. I think you had yours set to gold. So the material, let's just set it to gold. There we go. Oh, and you know what we should do? Actually, we don't have any begin play, we need to let's set this default material here. So let's set the default material to whatever the cube is set to. Oh, whoops. There you go, get material. Okay, I didn't do this part before. I'm kind of lost now on what I'm doing. Get material. We only use one material, so I should be able to just do get. Don't worry too much about this part. You know what, that didn't work. Let's just ignore that. We should do that, but I am not going to worry about that. So we will just set that in each instance because I'm not really sure what I'm doing there with this default material. So what we can do is set it here. So you would go set def material, and then we can just hard code it here. So this is the starter cube, so it's gold. It won't ever change in the starter one anyway, because we're not calling this function. But just to be consistent, let's go ahead and set it there. Okay, so then next we've got our metal cube. Whoops, I don't need to drag it out there, I just need to modify it. Okay, so we will go up here. Let's change our used copper, right? So we change that to copper. And then we're going to connect the parent play and then the tick. And this handles all the logic for making sure it's energized or not. So the metal one needs to be conductive. So let's make sure we set that. So we will set conductive. So it is conductive. And then we can go ahead and set this default material. We're just going to hard code it because I don't know what I'm doing with that. I don't really work with materials a lot. And copper. That way whenever it gets de-energized, it switches back to copper. Okay. And then let's go ahead and set up rubber. Let's do glass or something obvious. I don't think I have your what was the statue glass? Might be a little better. Yeah, probably a little better. Okay, so then make sure that these are running. And then we're going to set conductive to false. And then we could go ahead and set, for the sake of consistency, the default material. It won't matter on this one. What do we do? Statue glass. Okay. So one thing that I forgot to do here, which is convenient, I think, for helping us visualize when they are... oh no, I did. I set the material. We set it to chrome. Okay, good. So then did we change it back in the de-energize me? Yes, we did. Okay. Sorry, kind of forgot that I already did that. Alright, so I think we're done setting these. So then here in the level, let's go ahead and drag out a starter cube. Is that at the bottom? Yeah. And then we'll put a rubber cube in. And some metal cubes. Let's not quite set that touching. Set a few more metal cubes in here. And then set another one over here so we can kind of test to make sure that the non-conductive surface works also. And let's see how this plays. Let's see what happens. Can I push these? No, I can't. Oh yeah, I can. There we go. Well, that didn't work. Let's see what's happening here. So let's actually just make these touch from the beginning and see what the error is here. See what's going on. We have this found energizer. I may pause this if I can't figure this out in a minute and then come back to it and let you know what the problem was, so you don't have to sit here through all of this. But this is how I would go about debugging it. So we're gonna check. No, I don't want to do that. That calls on every tick. Okay. You know what? Let's get a overlap event. This will call whenever there is an overlap. I just need to make sure that the overlaps are working correctly on these actors. So we'll just print a string. Print string. This just shows up. This is developer only, but it'll show up in your in the game up in the corner, and we can just see what it's overlapping with. This will just give us a quick indication. Are we generating overlap events? I'm just going to simulate rather than play. Okay, that's calling 2. This is false. Oh, you know what? We might not have... Let's go back to the viewport. Whoops. Okay, so we are getting overlap events. So I probably just have something wrong with this not being set to conductive or something. Let's simulate. Okay, it is set to conductive. Okay. Alright, well let's try. I'm going to set a breakpoint here. And let's try this again. You know what, this will be easier if I disconnect all of these so that we only get one overlap, and we can just check this one. False. Okay, so this is a starter cube. Let's skip a few frames. See, it's not getting the energized. So energized on our starter cube is not getting set, and that's what's causing the problem. Let me see if I can figure out why. Starter cube. Set energized. It's not setting it to energize for some reason. Or it's not properly retrieving it. I'm gonna go ahead and pause this. Give me a minute to figure this out. I guess I can't pause. I will just have to end this